we're going to start 7.2. 7.2, technically this section is anti-differentiation using, I know it's a huge word, substitution.
Wait, my pencil. Here, I got one. Well, I got another pencil. I think that's why this one's here, because they gave out another two.
Yeah, I think Kaden left it there. All right. Huh? Yeah. So anti-differentiation was what we were doing last week. So real quick, just a reminder. Here, we'll do a reminder. Remember, if I had the integral of, let's say, sine x plus 3x squared dx. To find the antiderivative of this, antiderivative of sine x was negative cosine x. Antiderivative of 3x squared was 3x squared, or 3x to the third over 3, or x to the third. And since this doesn't have bounds that go from a to b, what do we put at the end? Plus c. That's it. That's what we were doing last week. You remember that part, right? Okay. So the first few problems in your homework today just take you back to what we were doing last week. Okay. The new part of today is that sometimes we have to do a substitution. All right? So, for example, if we have an integral of, let's say, sine x to the third, 3x squared x to the third dx. So we got a lot more going on in here, right? We have two things that are multiplied together. There's a product in there. And there is no way for us to do the product rule in reverse. So what we need to do is do a U substitution. In this case, just like we did when we were doing derivatives, we are going to take the most inside thing and make that a u. So our u would be x to the third. So then anytime we have a u, we do a du. Du then would be 3x squared. Now technically, even though we never used it, there's a dx that comes after it, right? So you'll notice that this part was a u, and this part together makes a du. So then I really have the integral of sine u du.
Right.
So now antiderivative of sine u is negative cosine u plus c. Well, now we got to plug it back in now. So this ends up to be negative cosine x to the third plus c. Okay, so by doing a u substitution, you're seeing where the du is taking pieces together that you really don't need to worry about. Okay.
I'm right on here.
Are ya? All right. So let's try another one. So here is actually, let's try another one using substitution. So let's go with example number 1. Using, whoops, not spelling very well. All right. If I have the integral, let's say, of x squared square root of 5 plus 2x to the third dx. There's a lot going on in there, isn't there? So the first thing I want to do is do a u substitution. Now, what does a u substitution? We want to take the most inside thing, right? Same thing we did with derivatives. So our u would be 5 plus 2x to the third. Our du, good, is 6x squared dx. Let me move that out of the way real quick. Dx. All right, so you'll see I have the x squared and the dx, but I don't like that 6 in front. That 6 doesn't work for me. So in order to get this to match what I have in my integral, I'm going to have to divide both sides by 6. Okay, so in my integral, I technically have the square root of u, and then the x squared in dx gets replaced with 1 over 6 du. And I'm writing it that way so you can see where the pieces go together. All right, so now, this piece right here, anytime we have a coefficient, where can we put that with our integral? In the front. So I'm going to write this as 1/6, the integral. Is there a better way for me to write the square root of u? Yeah, so I'm going to have u to the 1/2 du. Now we're going to do the antiderivative. Oops, move up a little bit. Not quite that far. There. All right, so I have 1/6. Antiderivative of u to the 1/2 would be u to the 3/2 over 3/2. And if I put 3/2 down here, that really means that I'm going to multiply by the reciprocal, so 2/3 plus c. You want me to say all that again? So then, can we simplify this up at all? Do you see anything that will cancel? Top and bottom.
2 and 6.
Good. So 2 goes into 2 once, 2 goes into 6 3 times. So our final answer, well, almost final answer, would be 1 over 9, u to the 3/2 plus c. Now we've just got to replace our u. So we can say we have 1/9. Our u, we said, was 5 plus 2x to the third. That's all raised to the 3/2 power plus c. All right. Let's try another one. Example number 3. No. Oh, yeah. Sorry, my bad. My bad. All right, so we have the integral. Let's go 5x over 4 plus x squared dx. All right, so first we got to decide what our u is going to be. Now, there's nothing on the inside, so the next thing you should look to is the denominator. So we're going to use the whole denominator as our u. So I have u equals 4 plus x squared. So my du is 2x. So far we know that this piece on the bottom is u. Somehow I need to get this to look like 5x dx. Well, I left off my dx. Sorry, guys. So how do you want to do it? Okay, we could do it by 5 halves, right? We could, again, there's a couple different things, so I'm going to talk to you guys. You tell me what you want to do. Technically, we can move this 5 out in front right now, so it's x dx, and then divide by 2 here. So we have an x dx on that side. You like that idea? Okay. All right, so let's go ahead and get this to be x dx over here. So I'm going to divide both sides by 2. So I have 1/2 du is going to equal x dx. Over here, I'm going to move this 5 out front. So I have 5, the integral of 1 over u times by, so for the x dx, I get 1/2 du. So now I can move this 1/2 out front, so we end up with our 5 halves that Logan mentioned, right? So I have 5 halves, the integral of 1 over u du. What is the antiderivative of 1 over u? Yes. So this is where we have our 5 halves. The natural log, absolute value of u plus c. Yeah, that's when you go backward and it's not a derivative anymore. You're going back to the original. The du goes away, right? Okay. So now the only thing we have to do is replace our u with 4 plus x. So we have 5 over 2, the natural log, absolute value of 4 plus x plus c. And the reason we have to have those absolute value lines there is because whatever we were plugging in, we have to make sure that it's positive. Oh, did I lose that? Thank you. All right, so let's try another one. And then I'm going to break it down so you see exactly where everything's going to go. Hold on, sorry, I just got to get to another good example for you guys. All right, so let's do this one. Example number 3. Let's say I have the integral of 5x to the 4th secant squared x to the 5th dx. Nope. So what's the innermost, and that's what I want you guys to see, gentlemen. Yeah, we're going to use the innermost thing is x to the 5th. So u equals x to the 5th. That means my du is 5x to the 4th dx. Yeah, so this is my u right here, right? My 5x to the 4th and dx get to be the du. So let's rewrite and see what we have. I have the integral of secant squared u du. Antiderivative of secant squared? Tangent. So I have the tangent u plus c. Yep, so then this is just the tangent of x to the 5th plus c. Okay, so there's times where you got to do a little manipulating with the dx part to get it to match, and sometimes it's straight up like this one.
They like to call me master manipulator.
Okay. All right, so let's break it down a little bit more, a little closer to what the homework's going to look like. So here we are with example number 4. Example number 4. Again, I haven't decided what problems we're doing yet. So 1 through 6, right? This is 1 through 6. All it asks you to do is find the indefinite integral. So it's called an indefinite integral when you don't have bounds to evaluate. So let's say I have something that looks like this. The integral of, how about 3x to the fourth plus 2x to the third minus 7x dx. So are there any things in there that are a product or something inside of something else? No. So this is straight up antiderivatives. Okay. So antiderivative of the first one is 3x to the fifth over 5 plus next one is 2x to the fourth over 4 minus 7x squared over 2 plus c. So yes, now we can go back and simplify it a little bit. So we have 3x to the fifth over 5 plus 1/2 x to the fourth minus 7x squared over 2 plus c. So the first 1 through 6 is what we did before. Example number 5. This is going to be your 7 through 12. No. Good try, but no. All right. Use, we'll see, differentiation to verify. So for example, if I have the integral of e to the 2x dx, I want you to show that that equals 1/2 e to the 2x plus c. So it says to use differentiation, which means it wants you to do the derivative of the right-hand side to see if you get the left-hand side. All right, so first, if I am doing the derivative of this side, so I'm going to do the derivative. I'm going to put a little prime there because I want to do the derivative of that side. I technically have to do a u substitution for the 2x, right? U equals 2x. Du would equal 2. So I would have 1/2 e to the u. I still have plus c. Now if I do the derivative of this, I get 1/2 e to the u du. What's the derivative of a constant? 0, exactly. We say a constant because if it's a number, whether it was 4, 7, 10, remember when we were solving for c, it was just a number? That would drop out when you do your derivative. And so now that I have the derivative, I can go back and plug everything in. So I have 1/2 e to the 2x times by my du, which is 2. My 2's are going to cancel, and I'm left with e to the 2x, which is exactly what we have right there. Okay? So on these problems, you're doing the derivative to get it to match what's inside the integral. Everybody okay with that? Do we want another example of that? No. Okay. Let's go to example number 6 then. Huh? Yes. They're all going to match. It's just doing the steps to get it there, because then we're going. Now, technically, because that's when you put it into the integral, you're saying it's the derivative. That's what that says. Okay? All right, example number 6. Example 6 is your 13 through 16. Yeah. All right, so in this one it says verify that the integral of f of u du is not equal to the integral of f of u dx. let's start with, let's say I have f of u equals u squared. And I'm going to tell you that u and u equals x to the fifth. So we're going to start here with this first part. I'm going to say I have the integral of u squared, because I'm doing f of u, so that's u squared du. Right? Okay? And then, if I were to do that, the antiderivative to this would be u to the third over 3 plus c. Do you agree? Okay? And then if I were to take my u and plug it in, I would actually have x to the fifth raised to the third over 3 plus c. Or we can say that's x to the what? That doesn't look good. 15th. Very good. Okay. So now we're going to do it the other way. So we're actually going to do the integral of f of u du. So we're going to say f of u, which is u squared du, but this time we're going to plug in our dx's right here before we integrate. So we're going to have the integral of x to the fifth squared dx. So that's really the integral of x to the 10th dx. What is the antiderivative of x to the 10th? Yes, x to the 11th over 11 plus c. Do these match? They do not. Okay? All of them in this section are going to show you that they are not the same and they do not match. All right? So obviously these are not equal. Not equal. All right? Example number 6, and this should be our last one. And I'll decide what we're going to do. Example 6. This is, oops, wrong part. Number 17 through 24. Use the indicated substitution. So in this section, they're going to tell you what the substitution is. All right, so that you don't have to figure it out yet. They're going to give it to you. So for example, let's say we have the integral of x cosine of 2x squared dx, and they tell you that your u substitution is the 2x squared. So if I have my u substitution, the first thing I have to do is find my du. So my du, of course, is going to be 4x and dx, right? Well, you'll notice over here, this becomes my u, but I only have an x dx. I only want the x dx. What am I going to do with that 4? Divide by 4 on both sides. So I'm going to have 1/4 du equals x dx. So then my integral over here, what can I do with that 1/4? Do you want me to write it in steps first? Yeah. So I technically have the cosine of u times by x dx, which is 1/4 du. I'm going to write it that way so we see it until we get used to it, right? So now where can we move that 1/4 to? Outside. 1/4. The integral of cosine u du. Antiderivative of cosine is? Nope, good try. Sine. So it's 1/4 sine u plus c. So what's the last thing you have left to do? Plug your u back in. So we have 1/4 sine of 2x squared plus c. So in this section, they're giving you your u's. All right, it's more getting used to how are you going to put your du in for what they have in there. All right, any questions? Okay, so let's see. What should we do for an assignment?
I'd say 1 to 16.
Well, I had 1 to 23 odd, and I was worried that wasn't enough problems.
I was worried that was too many problems.
That's plenty?
I was worried that was too many.
All right, we'll stick with the 1 to 23 odd then. Yeah, I was worried it wasn't enough, so. So we really only have, what, 4 new problems to do. Everything else is all stuff you've done. Maybe the verifying might be a little funky to begin with, but you'll be okay.